Welcome to another live learning session with me, your host Yujin Tang. You'll notice that I'm now in a different corner of the screen. I've decided that we'll just make this screen a bit bigger so you guys can see more. Anyway, from the last time when we were checking out the CNNs, I have posted that question to Stack Overflow, but it was just a couple days ago, or maybe yesterday, maybe this morning. Today's Saturday. I think it was yesterday. But it hasn't been answered yet. Not terribly unexpected. Anyway, I have tried one more thing since I checked it out. Since the way that we were implementing model earlier was actually to just pass the data to the model like this. So here what I tried was to create the model and just call this forward and print it out as we move through the model. And so, I just redid that, reset the model, make sure the model's the same basically, and then we call it and we're still getting this. So I don't really know why that is. But it happens even if I don't call it happens regularly with this stuff. So somehow it works when you just call the CNN still. This is going to be something that probably takes more exploration that we're going to have to look into later. I'm going to stop this because I don't really care. So now I think we've been talking about doing k-fold validation on this for about 3 or 4 videos now. So this is how you know this is a good reflection of software engineering. We're doing it live. Things never work out as exactly as you would expect. So what we're going to do now is we're going to actually do a implementation of a k-fold validation. Basically, we're going to do a k-fold split and try to get this all done right. And so we're going to do this slightly differently. So I'm going to rename this and just call this CNN exploration. And then I'm going to, let me correct this on Git. So Git status, right? Git. Let's see if I've changed anything. Haven't changed anything. Okay, Git commit -m CNN file name change. Git push origin name. Okay, so I probably need to go change my Stack Overflow question to reflect the correct Git file. So I'm gonna go do that really quick, and then I'll pause while I do that, and then I'm gonna come back and we're gonna make a k-fold validation tutorial, or the k-fold validation function. Okay, I'm gonna unpause this because I decided to do a couple more different experiments. So I'm gonna let you guys see what we're doing here. So we're going to print out this x.size so that we can understand a little bit more about what's going on. So this is 64 by 1 by 28 by 28. Okay. I see what's going on here. So what we actually need to do is implement here. We need to do 64 of these. And only one element tensors can be converted to Python scalars. Okay, so I screwed this up. So the input needs to be 64 of these. So I think what we need to do is this. Is it this? Too many indices for a tensor of dimension 1. Maybe it's... Okay, how do we do this in the train loop? So once again, this is more research than software development, but we're not really doing oh geez, what does the size look like? This is, we're checking a lot of different things right now. So the input size of 64 by 1 by 28 by 28. So I think what we need to do is, let's do this. Training data. Okay. Jeez, okay. Can't even. Okay, let's do vstack. Is it tensor PyTorch torch.tensor vstack hstack? Oh boy. Stacking tensors in PyTorch. This is regular stack? Torch. Just torch.vstack, okay. Torch.vstack. Training data. Dot size. Training. So here we're gonna try to stack two of them. Expected ends. Okay, so that's not right. What about just stack? There we go. This is what we want. So we want to stack x for x in range 0, 63. Oh my god. Okay. Here's what we're gonna do. Turn a generator into its generated object Python. Let's see if that's actually possible. Can we do this? Can we call it a list? Ah, here we go. Cool. So we need 64. So that's what we want to pass in. So we're going to call this input. And then we're going to model. Not what I want to do. Switch slide type. How do you? Here we go. Python. And then model input. And we'll redo this. And we'll redo this. So let's do this. Model should be the same. Now let's try it out. Ah, yes. Okay, cool. It tells us the sizes, though. Now we get to see how everything works. Wow. Okay. It took us like 3 videos to get to this, so it's going to take us like multiple videos to get to the k-fold validation stuff. Just because I want to have like separation between all the videos. But this makes a lot of sense now. Cool. Okay. Let's get rid of this because this is... Cool. So when we print out the model, we need a batches of 64, which is why it didn't work in the first place. Okay, so now I can go answer my own question on Stack Overflow. That's always fun. So let's see what happens. 64, 4, 26, 26. So convolutional 2D. 64 by 1 by 28, 28. So that's what the input is. And then it becomes 64 by 4 by 26 by 26. ReLU stays the same. MaxPool with kernel 1 stays the same. Flatten turns that into 64 by 2704. And then linear turns 64. Yep, 64 into 64. Yep. And then 64, 64, and then 10. Yes, okay, cool. So let's see what happens when we do kernel size 2. Now we get to like fuck around and find out. Great, 64, 64, 13 by 13. Now we're gonna see what's going on here. Kernel size, why is it dividing by 2? Is the stride here like dividing by 2? Let's see what happens when we make it 3 by 8 by 8. So I guess it's what it's being divided by, and then it's being floored. So if it's 4, we should have 26 divided by 4 is 6 point something. So we should have 6 if we make a kernel size of 4. I guess. Yeah, okay, now we have an understanding of what kernel size does. It's just dividing the dimensions of the... Which makes sense, I guess. So kernel size should happen similarly to the way that we expect the kernel size of the comp2D to happen, except we're pulling it all into one thing. Okay. Cool. I hope you guys understand that. If you don't understand that, I will drop I'll drop like a short explanation. So I'm going to write this down into my to-do list. I'm going to drop a short explanation of how the kernel size works. Cause like these formulas, like don't intuitively make any sense to me. And I assumed that other people like probably like they don't make any sense to you either. But if they do, you are welcome to write about why that makes sense to you in the comments and give a better explanation than what I've just done, which is kind of like fuck around with the code and trying to figure out what it's doing. Anyway, now we know that it works. Next time we're going to do k-fold validation. So this is a rather short one, but it was good. So thanks for watching, and I'll see you guys next time. Remember to subscribe.